So finishing up the example with the phones, letter G, what's the probability that at least one student picks up his or her phone? And I'm going to give you a hint, there are multiple ways to do this. I think, all right, first of all, I want to say probability of at least one. Well, like I said, there are two different ways to do this. The first way, in a way, the easy way, uses number 3 here. If the probability that an event does not occur is 1 minus the probability it does. So at least 1 would be 1 minus the probability that it doesn't happen. 1 minus the probability that there are 0 matches, because then there could be 1. At least 1 means there could be 1, 2, 3. Well, there can't be 3 because that can't happen, but 1, 2, or 4. So this is called the complement rule. We're going to get more into this and then later in this note set. But we could find that by just taking 1 minus that probability of 0 matches. Go up here, 0.375. And I get 0.625. Or another way I can do it, I'm going to get the exact same answer, is if I want the probability of at least one match. Well, at least one, I could have probability of 1 match, and then, or probability of 2 matches, 3 matches, or 4 matches. Oops. I'm just using M for a shortcut here. In other words, at least one means it could be 1, 2, 3, which we already know the probability of that is 0, or 4. Now, if you have exactly one match, can you have exactly 2 matches at the same time? No, you either have 1 or 2. So this is and it's called the addition rule. And once again, we'll talk about that more later in this note set. But if we add them up, we would literally just take the values right from the table and add them together. Zero 0.25 and 0.042, and you're going to get 0.625. You're going to notice those values are the same, and they should be. This is using that last rule, the mutually exclusiveness. Once again, we're going to be hitting mutually exclusive and this complement rule here many more times. This is just an introduction to it. Finally, what is the disadvantage of the exact mathematical analysis as a strategy defining probabilities of certain outcomes events? Well, it can take a lot of time to write up that sample space, but honestly, we don't always have to write out the sample space. We need the size of the sample space and how many events that we're interested in occur in that sample space. But we'll be doing counting, using some counting strategies, but that'll come down the road. At this point, we're going to be able to enumerate, in other words, write out the sample space. The next example, 2.2, I'd like you to work on your own, and I will have the solution posted in the end canvas.